or to the cloud. There we go. So can everyone see my screen here? So Git.
Yes, I can
Can
see
you
your
see?
screen. I hope it's the
Can you see
intended one.
the Git website?
Yes.
Yes.
Perfect. Okay. Cool. So first things first, I'm going to talk about Git already. I think I already gave an introduction to Git. We had a presentation by Dalton a while ago on what Git is. But all in all, Git, so this website, so the tool that is called Git, it is a tool that allows you to back up and create versions and iterations as you are developing code. People use this for software development, they do use this for anything that you're doing while you are collaborating with people and creating versions. So imagine you guys are developing a new software. Let's call it the Gemini software, for instance. And you have the software Gemini 1.0. So this software is available for all users. Timot downloads it, Gabi downloads it and use it. And then the company that develops Gemini decides to do a new version. It's going to be Gemini 1.1, which is going to bring new features to make the software more usable, right? If you would go and in the same version, the same file, the same code base you had for Gemini 1.0, you would make changes to that, it's likely gonna break the code, the execution of the code for the 1.0. So Git would allow you to create a copy. So suppose that this one here, this pack of files is the oldest version, the 1.0. You can create a copy of it, call it 1.0 test, and then do the changes on this branch in order to get to the new version of the software. Once you get the final version ready, you can then transform the 1.1 into the actual main version. So this is just an example of let's say in our case, we are working with a data analysis codes for a big project and we want to make changes, but we basically don't want to break the changes that we made in the past. So we want to make sure that everything works. We could do the same thing by creating versions of this code, or at least backing up the code in a way that if something is wrong, we can always go back to the oldest version and have it functioning again as it was. Does it make sense?
Yeah, it does.
Have you, any of you used Git before? Either in R, Python, or seeing any classes before?
Yeah, I would say I have, but I mean to a very limited extent.
Okay,
Yeah, the same to me. Yeah.
sounds good. That's fine. So let's go into the basics. So Git, this thing that I'm showing here, Git is a software that is going to be needed to be downloaded and installed on your computer. So here you can see that I have a button to download for Mac because my system is from Apple, but you can easily download for Windows, for Linux, and for many others. And for some of the systems, it's already installed from scratch. I think if you have a Mac or a Linux, it's probably already installed on your system. But this thing here, Git, only works on your machine. So basically, it is something that is local. It's going to create the backups, it's going to create the versions, it's going to create the branches, etc. on your machine. But this is the basis to connect to the two other resources, which are the most known, which are GitHub and GitLab. Let me take the first page here. I don't think it's showing, but okay. So these two solutions, GitHub and GitLab, they are companies, they are solutions that were created to transform that thing that you had on Git, which is local, to something that works in the cloud. So if you have a company, if you have a group of users, you can have and save and back up your code in the cloud in a way that you can contribute, you can edit, send these changes to the cloud, and someone else can download those changes, can make the changes and continue the development. Either one works just fine, right? Just GitHub or GitLab work just fine. Just to show you how it looks like, let me go to my main page here. So this here is my profile for GitHub. I do realize that this picture is not, it is kind of old, so I need to update it. So bear that in mind. But you can have your project, and you can have similar to like a social network in a sense that you can follow people that you are developing. You can join projects. But the main part of the GitHub is the creation of the repositories. So you have, for instance, this one I created some time ago for the TLC pilot project. This one here is a repository that I created to teach R to some students at the time. And anyway, you can do a bunch of things. You can have both private repositories and public repositories. By public, what I mean is that if I go here and I copy this address, I can type it in the chat. You're probably going to be able to open, see the codes, download the codes, copy and use it as you see fit. Because above all, the intent with Git and GitHub is so it's open source, right? So the development of code that is open to the community and it's built by the community as well. So if you would, go here in the search bar and search for something like, I don't know, OpenAI, let's see if I can find anything. You could probably find codes from the actual OpenAI company. Let's see if that's the one. I don't think this is actually the OpenAI, but you can find codes from companies such as Facebook, Microsoft, that actually develop the software and make the code public. This has many advantages in a way that both the community can see the codes and see if it works for them and make suggestions and edit and make the code base grow and grow. But also for an enterprise world, if you make your codes for your software available, a company that wants to use your software can actually take those codes and do the tests and make the software compatible across everything. A simple example is, I don't know, Google Chrome, for instance, is a navigator, and you want it to work in Mac, you want it to work in Windows, you want it to work in Linux, you want it to work in everything, in a cell phone, in a Apple phone, Android phone, anything. So that's why you would basically share your codes. But in our side, in academia, this tends to a point that is very important, which is reproducibility, right? So if you do your analysis using R, using Python, using Stata, usually the journals ask for you to share your analysis codes. So it's reproducible. It is something that can be audited and evaluated. So this is a good resource for you to use. A quick example for some of this is, let's see, I think we have a Node Gemini GitHub here that is kind of getting replaced by GitLab, but I'm going to tell you about it in a minute. But for an example, we have, let's see here. So this repository, which is called Cracked 3 months, it's a repository that we created to share the codes that were used to do the analysis for this paper. This is currently being resubmitted. It's not published yet, but we do have a preprint available. But what we did is that we created this repository and we added the abstract, for instance, for the paper. We added the authors, and we also added the codes. So if someone wanted to check how the code works, they could come here and actually look at the codes and say, hey, there's something wrong there. Hey, this makes sense, or let me do something similar in my study in the future, right? The important thing is you need to be really careful if you are sharing sensitive things like data, patient data, key passwords and all of that, because if you make this public, everyone is going to be able to see. And once it's in the internet, it's forever in the internet, right? So you need to be very, very careful with that. A solution to try to circumvent some of those problems is using GitLab, and more specifically, Duke GitLab. So if you search in Google for something like Duke GitLab, you're going to get this here. So let me try to log off so I can show you the whole process. So if you search for Duke GitLab at Google, you're going to find this. You can log in using the standard multi-factor authentication using the Duo Mobile, all of it. So it's, safe under the Duke computing environment. So that's good and safer to use. And the GitLab can also be connected to a bunch of other resources at Duke. So let's say you are working with a virtual machine, like you're doing some analysis and you don't want to use your own computer for some reason, or because of some safety concerns, you can use some virtual machines to do it. And those virtual machines can be directly connected to the Duke GitLab. So I can post this in the chat so you guys can log in and have your first look at your GitLab page. But inside GitLab, much like GitHub as well, you can create repositories, you can create groups. And what we've done is that we have one that is called Gemini. And under Gemini, we can create separate groups, separate repositories for each project. This is going to be important because not everyone has access, or IRB access for all projects. And we want to do in a way that, we can clear the access for each project separately. But as an example, we have this, where is it? I believe we have one that is called Toolbox. Let's see if it's here. Where is it? Gemini templates, maybe? Yeah, I think it's called Gemini templates, actually. So this one is something that I started to build, and I'll make this public with everyone in Gemini, which is if we have a template, like we had Edwin presented to us some time ago about the linear models, we're going to have a template here that is going to tell people, hey, this is a quick way for you to do a linear model if you need on your analysis. Then you can pretty much download this, change your data set, change your variables, and run it. Or, for instance, here, machine learning. These here are template codes that I used in some other project for doing machine learning in R. So now we have it saved. And then you can basically download here and see I have a bunch of comments and all of those things that I've been producing throughout these meetings and through the template bidding exercises, they're going to be here for people to access. So this is something that should be public within Gemini, right? So I basically could come here and get to members, and I can add people here. For instance, Timo, tell me your net ID.
Oh, TAP48.
TAP48. It's not finding here. Can you tell? Is it Timo dot
Peter.
dot Peter? Maybe it's a bit different. Peter at duke.edu, like this.
Yeah.
Okay. So I'm going to invite you as a developer, and you should be getting a invitation on your Duke email for you to create an account and for you to join. And you're going to be able to see this. Okay. So this is one thing. We can create those repositories. We can create groups. For instance, we were working with folks that are developing the AUBPT project. That we have a bunch of undergrad students and some other students that are joining this project. And what I did is that I shared, where is it? Members. I shared invitations with a bunch of people so they can start joining and see the project going. For now we have, who's this? This might be Mia and Paige and Happiness that joined. But I invited other people to join as well. All right. So this is the first step, an introduction to the overall software, how it looks, the groups. Does anyone have any questions for now on why should we use it, or how does it work up to this point?
Yeah, my question could be, what is the reason of putting it in the GitLab when put it as a private project?
Cool. Good question.
Yeah.
Good question. So GitLab can be public as well. So let's see, I'm going to come here to my home page. So these are my projects. I'm going to create a new project, like blank. So I'm going to call it my first project. And you can see how you can select private, internal, or public. So private means that I need to, if I'm the owner, I need to invite you to join so you can see it. Internal means that anyone at Duke could actually see that project. And I mean, for this one, we mean Duke because this is a Duke-sponsored GitLab. But if you have your own GitLab or your company GitLab, it's going to be on that scope as well. And public, it means that anyone whatsoever can see the project. This is going to be different for, let's say, something that is being developed by us. We are in the middle of the project. We are doing the analysis. We're going back and forth. So we are not in a stage where we can actually share this with everyone in the community, because we want to make sure that the tables are ready, the graphs are ready, the analysis is correct, and if there's any mistakes, we want to fix it. Sorry. By the end of the project, we are then ready to publish the manuscript, and we want to actually make this public. We could change the visibility from private to public, and then people would actually be able to see, hey, this is what they did, this is their code, this is their analysis. But still, it might be a situation where you might have files that cannot be shared with the public. It's quite common when you have a publication that you can share the analysis data, but not the raw data. What I mean is, for instance, for qualitative research, often you cannot share a whole interview for the person, because that is, you can easily track down and identify the person if you go through the whole interview that has been recorded. It is common that you would share the code book or the summary of those interviews. So that's the reason where sometimes you want to have a directory, a repository that is strictly private. But then once you're done, you can create a second repository, which is published so-and-so paper, and then you will have it as public. That's the general idea.
Okay, thank you, Joe. Yeah, it sounds like the way we are also doing in the social medias, right?
Yeah, similar.
Yeah.
Yeah, Joao, another question. I hope I'm not kind of fast forwarding. But just imagine a situation that you and I say are working on a project, and at a particular time T, we are both making changes. I mean, what is the compromise? How does a system manage that?
Good question, and that is a bit forward. I'll get to that in a few minutes, but that's a good question.
Okay.
Cool. But now you have your project. I'm actually going to create a new project here so we can see it. So I'm going to come here and I'm going to create, actually I can create a public one so people can see and maybe join and see the updates as we go. So my test project, I'm going to make it public and I want to create a repository. Oops, I need to create users. Let's see. So one of you try to open this link and see if you actually can look at you can actually see the same as I'm showing now. It's also a nice test to know if it's working.
Yep, I can see.
Cool, perfect. So basically it works. Oh, I did something and my camera went to my cell phone, which is weird, but here it is. I might have clicked on this wrong thing here, sorry. Anyway, it works. Cool, so we are able to see. So how can we go from this to actually coding in R and doing the analysis and committing everything? So for every repository, either in GitLab or GitHub, which was the one I was showing before, you can come here to code and you can clone the repository. And by cloning, it basically means you are creating a connection between what is in the cloud and what is on your computer, on your machine. You can clone it in multiple versions. You can use an SSH key or a HTTPS protocol. They both work similarly, but the SSH is kind of harder to set up. It's you create a secret password that is saved in a file on your computer and is used to authenticate the connection. And usually the HTTPS is kind of simpler because you can have a password and it kind of works. But I'm gonna click here on clone with HTTPS, but you could also download this as a file. So it is quite common if you're doing courses, our courses at Duke, that they send you a repository at Git that they say, hey, download these files because we're gonna do this thing, and I want you to follow with the files that we have. That is a quite common way of doing it. And maybe when we have a next R workshop at KCMC or at Duke, we're going to do something similar so people can start using it more and more. Anyway, I'm going to clone it with HTTPS. I'm going to open my RStudio. And when you download Git and you set up Git, there are a few extra steps that you got to do, but essentially you can come here to the right, click on New Project. Let's see, it is opening. Yeah. And then you're going to click here on version control. So you're creating a new repository, a new project in R using version control. I'm going to use Git as my source. And you can directly paste the link that you copied here. So you see how it's called GitLab, blah, 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 mytestproject.git. I can select a name for my directory, like my folder. I'm going to call it the same. So it's going to be my test project. And it's going to be saved in this path in my computer. I could choose the path that I want to save. I want to do this path. And then I click create project. So now if I go to my files, oops, sorry. I'm in here. You can see that on my Gemini folder, I have a tab called My Test Project. And if I open, I have this file that's called README. which is a standard. Every time that you create a repository, it creates this file, which is basically saying it's a file for you to add instructions. And if you look here in this README file, which I opened in this text file, it has the same exact information that is in the website that I told you guys to access with the link. So if we come back, you're going to see that we have a title called My Test Project, and then a subtitle called Getting Started. And you have the same thing here, My Text Project, Getting Started. So you can see how it basically created a clone from the cloud to your machine. So that's working. All right. So this README file is a template, right? It is not by any means specific to your project. So let's start doing some changes to it and actually make it tailored to what we are doing. So we're going to call it, we're going to replace this and say introduction, right? And we're going to write some text like, this is a project that I am conducting with folks at the Gemini Research Center. And I'm going to delete everything else because it's basically not useful. What I can say is that I can add a new section, which is objective. And I'm going to have it here saying the objective is to get to know how Git works. And then we can have some placeholders like we have on a manuscript. We can have methods, we can have results, we can have discussion, conclusion, whatever. So I'm going to have these as placeholders because then in the future, we can come back and fill those in. I'm going to save this file. And even though I did save the file, the changes are not directly sent online. It's not like Google Drive. When you save the file, it directly updates. It's not like that. Why? When you come to R, and this is probably going to be the easiest way for you to use it, in one of the tabs here that you have, in my case, I have, my tab is down here, the one that I use. It has this thing called Git. Because I already installed Git and connected to RStudio. We can look into that when you guys are trying and how to make it work. But when you click on Git, it's going to look into your file base in the same folder that I told you that for the project. And it's going to list the projects, the files that are in there. You have a file that's called git.gnor. I'm going to tell you about it in a minute. But you also have the readme.md file. You can see how there are different symbols, right, between them. We have an M and we have a question mark. The M stands by modified, or like it's saying to you that there are changes in this file, while the question mark says that this file is not recognized because it's currently not in your file base. So let's go first with the README. I'm going to click on commit, and it's going to pop up this bigger window so we can actually look at it easily. And if I go to README, you can see that it's going to list to you the changes that were made in this project, in this file. So everything that is red has been deleted. Everything that is green has been inserted, right? So they list the changes. In order for this to go online, I need to first select and click on commit. I'm going to do it and you're going to see some error. It's going to tell you aborting commit due to empty commit message. This means that every time that you want to say, hey, I did some changes in this code, let's say that Kimonia was doing the analysis for a project and she's done for the day and she want to save the analysis. She cannot save unless she explicitly writes a message describing what she's done. So this is very important when you are working with code and working with other people, that you let people know what changed from one version to the other. So I'm going to describe here. I'm going to say deleted templated text, added description to project. Now that I have this description, I can click on commit, and it's going to say to me, the file has been added, and now we have 8 insertions, which is basically 8 new lines of text, and 87 deletions, because I deleted 87 lines. Now that we did this, it is showing us as a message up here saying that your branch is ahead of origin by 1 commit. It's telling us that, hey, the version that you have on your machine is more updated than the version that is in the cloud. In order for you to send those updates to the cloud, you actually need to click on push here. And if you do so, it is going to send those updates online. So now if we go back to the GitLab and we refresh the page, now you can see that we don't have that version anymore. Now we have introduction, we have a description that we had before, objective, etc., etc., etc. The visual is just a tiny bit different from the text from this version here, because when you do that in GitLab, it renders the markdown for you. So it turns into actual sections. But if you click on README and you click on seeing, I think that this is, yeah. If you click here to see the source text, you see that it is exactly the same that we did on the text editor. So this is how it works, the basic structure of it. How does it work with code? Let's create a sample code. I have this R file here that I want to save, and I'm going to call it analysis script. The first thing that it's going to show me in the tab for Git is that it detected a new file. So if I click here on the checkbox, it says A, which means added. If I click on commit, it's basically it's gonna start to track changes in that file, because since the file didn't exist before, Git was not tracking the changes as it was starting. So my message is gonna be first commit for analysis script. And let's say commit. Now this analysis file is being tracked. And again, we are 1 commit, 1 message ahead from the cloud, which is okay. I'm going to go to the changes. I'm going to say, hey, I'm going to start by, loading my libraries, and then do library tidyverse, and you can actually do something like this to load everything at once. So library tidyverse, library GT summary, whatever the menu packages that we usually use. I'm going to run. And then I'm going to have a section where I load my data, and I'm going to call it read CSV, blah, 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 CSV, right? So imagine we are going through the analysis and having this code. Now that we saved the file, it is actually showing to us that there are changes in the analysis scripts from the original version you had. Differently from before, the changes are only insertions because the file was blank before, right? Now it is all green. So I'm going to tell the Git that these changes are setup codes for loading libraries and data. I'm going to commit. Now it's our branch is ahead by 2 commits. I'm going to push this, and we should now be able to see this file Let's see. We should be able to see this file here, analysis script. So you can easily do this connection, do the track changes, share the codes as you go. Okay? Anyone has questions up to this moment? Want me to repeat any part? And then I'll go to answer Obali's question.
Yeah, Joao, not very related though, but I just wonder why you use the curly braces between the two library functions.
Oh, okay. This is because when you use the curly brackets, when you run one of the lines, it's gonna run everything for you. So sometimes you have 10 packages, and I don't want to run line by line. I put them like so I can run everything at once.
Okay.
Just a shortcut.
Yeah, I never knew that. Thanks for that.
Yeah. Cool. Other questions? Okay, cool. So we have the code files ready for you to download. So if I gave this, or actually you already have the website, and let's say that Timot wants to work with me in this project, and Timot wants to download and work with it. You could do the same thing using the HTTPS clone, but since this is not your repository, Timot, you would need to ask for my permission to upload the codes back to it. So I would need to give you access. The way that we do it, you can either come here to manage, click on members, and then again, invite members. So I could come and say timot.peter@duke.edu. I would ask you to be a developer and invite. Now you would have access when you accept that. But since the person is not directly the owner, you would probably need to create a access token, which is something that is a little bit more tricky, but it's gonna work just like a password. So whenever Timot needed to do the first commit message to upload the code, RStudio is gonna ask you, hey, what is your email that you're gonna use at GitLab? And what is your password? So these things need to be saved in a very safe environment. If you have like a password manager, that's a good resource, or maybe saving a file on your machine. Because if we give this password to someone else, they are going to be able to download, to delete, to edit the codes, and most importantly, see things that might be, sensitive, right? We don't want to share this password with people that don't have IRB approval, that cannot see the data, and even in more important aspects. For instance, if we're doing analysis, as me and Timot are doing analysis with the trial data, some people are not allowed to see the randomization information, right? Because of the blinding. So we want to make sure that first, this is not shared with the public. And second, people that should be blinded stay blinded because of the protocol of the study, right? But again, we can talk in case by case. Cool. And going back to Obali's question, we are working together, and for some reason, there is a mismatch or there is something wrong that we want to make sure that things work nicely. Ideally, Obali, if we are working together, we should communicate that, hey, I am done. I submitted all the changes online, and you are free to access and edit the code. Cool. And then you would do your part. You would say, hey, I'm done. Can you check my code again and see why it's not working? And you would basically tell me, I would download and make this thing work. How do you download code? I showed you how you upload using, you basically click on commit for the changes that you want to do. Basically, you can think of commit saying, hey, I actually want to make these changes real. I want to save them. So you click on commit. And for instance, in this case, I'm going to say new version for GitLab. And when you want to upload code, you're going to push. You basically push your updates online. So we're going to say push, and it's going to do the commit for you. But let's say that Obali was working in this project, and he did some changes. We can actually edit some files online. So I'm going to pretend that Obali is doing these changes here. And Obali came to the README file and removed the introduction. Because for some reason we discussed, and Obali decided to remove that. We can save these changes similar to what we would do just now. You can actually add a commit message, even doing it online. So remove the introduction because it is not needed. And then I'm going to just say the tag there, Obali, just so we know for this example. Commit. And they have been committed. And they should already be in place. Yes. Oops. Okay. Now, in our example, if we come to commit to the project, I'm going to close everything. I'm going to start again. Let's say that tomorrow, Obali, in the next day, Obali says, hey, Joao, the codes are ready. Can you help? Can you review? I'm going to open my RStudio. I'm going to open the project. So I'm going to come here on the right side. I'm going to select the project that we were talking about. And I'm going to come here on Git. And I'm going to click on commit. And I'm going to click on pull. Because I'm going to pull updates that are online from my machine. And it's saying that it's downloading from this address, which is my project. It is basically doing changes on only the README file. And basically there were 4 deletions because we deleted the introduction, the description of the introduction, and I think we deleted a few extra blank lines. So it's saying that there were 4 deletions. Now, if I go to my README file here in the right, you can see that I don't have the introduction anymore. So the changes that we did were then downloaded, and now we have the most updated version. There are many ways for you to basically, check if the version of your Git is the most current, and all of this can be done via terminal as well. So if you are fancy and you want to do codes in the terminal instead of using the RStudio IDE, you can. But it basically is just more trouble. This is the version. I think it's like Git status. Yes. So if you go to your terminal, so we have your console, I think usually it stays down here, but if you go console and then terminal, you can use this thing called Git status, and it's going to say your branch, so your version on your machine is up to date with the origin branch, which is the online version. So now we are current. It is also saying to us that there are some files that are not tracked, meaning that we created these files in our machine and they are not tracked online. So for instance, that my test, our project is not tracked. Nothing added to commit, but untracked files are present. And it's saying to you, use the command git add to track your file. This can be done with the terminal, but usually I just come here to the commit. I click here and I say first version of the R project. And I commit, push. And if I come here and I say git status, again, now it's saying your branch is up to date, nothing to commit, working tree clean. So everything is squared. all the files are updated, all the files are tracked, all the files are pushed. Everything is square. There are scenarios where maybe by some mistake, by some miscommunication, Obali did some changes and I did some changes and we forgot to update them. And it's gonna have a mismatch. While Obali's code might have, I don't know, 100 lines and mine only has 90 lines because I did something different. When you try to do that, it's gonna give you an error and it's gonna basically ask you which version should you keep. And then those exceptions happen where you need to make sure that things, which one to select, how to, go back to another version and all of it, right? That's the case. But for the most general use case, which I think it's going to be more beneficial to all of us here, is having at least some versions backed up. So as an example, I know that Obali is working on a dashboard for an application for the grid project. Maybe Obali already knows that he has a very good working version now, and he wants to save that as version 1, or say that, hey, this code works, I'm gonna save it. And then he has a meeting with folks in his group, and people give suggestions. People ask him to make edits, ask him to, do all sort of things. Then he's gonna create a new save, a new commit. It's gonna say new version with new colors, with a different font, new figures, and he's gonna save that. That is really, really important because in the future, if something happens and the code doesn't work anymore and nobody doesn't know why, he can always come back to that version and see the version that worked. So let me try to find one of the projects, Gemini. Maybe not this one. Here. No, that one could be good, yeah. History. So whenever you are in a directory, you can create on history. If you go to that one that I shared the link, you should be able to click on history as well. And you're gonna see all of the commits that you did before. So if something happened that after this meeting on October 16, we actually needed to come back to a version where the table font size was altered, I could click here and I would basically see where the changes happened. In this case, the only thing that I changed in this file was actually the font size that I used in my table. So from 9 to 10. So it's a very minor change. But there are situations where you change a whole figure, you change a whole model, you change a whole thing. So you can always come back to this history of versions and have those things recorded as you have here. All right. This is the general, the most practical look at Git, and I think that makes more sense for us as we're doing analysis, as we're doing tracking projects, etc. So I'm gonna open for questions, but I also want to call you guys up and say, whenever you start a new project or you have a project that you are currently working on, let's start trying to use Git to back those things up. So reach out to me later. We're gonna create folders for you guys at repositories. I'm gonna create access keys for you so you can start backing those things up. Even though in the beginning it's gonna be all messy, it's gonna be, we're gonna have problems here and there, it's good to have at least versions, even if it's in every big meeting between the group, we have a new version that it's saved and we can always go back to, okay? Then questions or comments from anyone?
Yeah, just a thumbs up to you, Joao. Thank you very much. This is a very important topic. Especially as we delve more and more into writing codes and developing dashboards and so on, it's very important to, to have different versions of our work just in case we hit some obstacles in the future and want to come back. So I really appreciate, and I don't know if it'll be possible to do something similar with Python. I don't know how they relate, but I suspect there will be some differences.
Yeah, you can. From Python, since you don't have like similar to RStudio, you don't have like you have many different IDEs, right? You have like a PyCharm, you have VS Code, you have many different developing environments. Each of them has a different way for you to use Git. But usually when people use the Jupyter notebooks, you basically would need to find a different way of connecting, but it would work just the same way. On the other hand, you can do Python inside RStudio, and then it would be just as easy to connect the same way as I did. You would use for Python files. It would be the same thing. But we can look into that about it afterwards.
Thank you.
My wildest dream is in the future where we are going to have everything nicely organized. And whenever we need to look into code, like Timothy is doing analysis, Gabi is doing analysis, etc., we are going to be in a stage where you're going to say, hey, João, I have this problem on line 155. It is not running. You're going to tell me I'm going to be able to download the code and go directly where I see the problem and either have the suggestions there or have a tiny fix there, or at least have that opening my machine while we talk through like in a meeting. This is the gold standard that we're gonna have in the future. But also for reproducibility, where if I do an analysis, I would like for someone to download this data, this code, and rerun and make sure that every step works, right? This is the dream, and we want to get there, right? This is the first step. The second step is you guys reaching out to me, setting up the projects, and starting back up your code as well, right? This is the first step.
Yeah, that sounds like a fun and somewhat peaceful future.
Yes.
Yeah, we look forward to that.
Yep. Cool. Anyway, thank you all for joining, for listening, and we're gonna have this as a recording so anyone can access in the future. And I think that next week we have Obali sign up to present to us a little bit about his work with the Greek project and one of the awesome applications he's developing. Cool. Thanks, everyone. We're gonna see each other next week.
Thank you, Joe.